Hi there, in this video we're going to look at metallic bonds. On the screen is two images, and we're going to start with the left hand side. So here we've got some electrons and metal atoms, and them electrons are in the metal atoms' outer shells. Now metals, as you should know and I covered in my ions video, they become ions because they lose electrons. So the electrons that these metals are going to lose when they become a metallic structure, like over here, this is the metallic structure, that is formed by the electrons being lost by the metal atoms. So here we have metal atoms, and over here these are positive metal ions. So that means that the electrons have been lost. So the metal atoms lose electrons to form metal ions. Once those metal ions are formed, there are electrons in this thing called a sea of delocalized electrons. That word just means it's no longer, the delocalized word means it's no longer near the atom that it originated from. So basically, the atoms lose their electrons and they are surrounding the whole structure, and they're just floating around while the metal and the metal ions are that structure. And as you can see, there are layers of the positive ions. So they're very rigid structure because there are those layers, a little bit like an onion, one of my students once said. Metallic bonds have layers like onions building up to make a rigid structure. So here's just a summary of that in words. So the atoms are arranged in layers. This is known also sometimes as giant metallic bonding if it's a larger structure. The positive metal ion, because it's lost those electrons, is surrounded by a sea of electrons, sometimes referred to as this delocalized, and that just means it's no longer near its originating atom. This attraction is really, really strong because it's between those positive ions and the negative charges of that sea of electrons. And this means that the properties of metallic structures are these. They're good conductors of electricity and heat, and that's because of the delocalized electrons, or the sea of electrons, cause it to be really good conductors of electricity and heat. High melting and boiling points, that's because of the attraction between positive and negative. So that means that there's a lot of energy that needs to be overcome to melt or boil the metallic structures, and it's very, very soft. And that's because of the layers that are in the structure. That means it's easily cut between layers. So that is a kind of run through of what metallic bonding looks like, some of the factors that cause it to become a metallic structure, and then the properties and how that links to the image that we saw right at the beginning.